earliest interbreeding between ancient human populations has been discovered, evolutionary puzzle has been solved. According to the University of Utah, Neanderthal and Denisovan ancestors interbred with a distantly related hominin 700,000 years ago. For 3 years, anthropologist Alan Rogers attempted to solve the evolutionary puzzle. His research untangles millions of years of human evolution by analyzing DNA strands from ancient human species known as hominins. Like many evolutionary geneticists, Rogers compares hominin genomes looking for genetic patterns such as mutations in shared genes. He developed statistical methods that infer the history of ancient human populations. In 2017, Rogers led a study that found that two lineages of ancient humans, Neanderthals and Denisovans, separated much earlier than previously thought and proposed a bottleneck population size. It caused some controversy. Anthropologists Maffesoni and Prufer argued that their method for analyzing DNA produced different results. Roger agreed, but realized that neither method explained the genetic data very well. Both of our methods under discussion were missing something, but what? Asked Rogers, professor of anthropology, University of Utah. The new study has solved the puzzle, and in doing so, it's documented the earliest known interbreeding event between ancient human populations, a group known as the super-archaics. In Eurasia, interbred with a Neanderthal Denisovan ancestor about 700,000 years ago. The event was between two populations that were more distantly related than any other recorded. The authors also proposed a revised timeline for human migration out of Africa and into Eurasia. The method for analyzing ancient DNA provides a new way to look farther back into the human lineage than ever before. We've never known about this episode of interbreeding, and we've never been able to estimate the size of the super-archaic population, said Rogers. We're just shedding light on the interval on human evolutionary history that was previously completely dark. The out of Africa and interbreeding. Rogers studied the way in which mutations were shared among modern Africans and Europeans and ancient Neanderthals and Denisovans. The pattern of sharing implied 5 episodes of interbreeding, including one that was previously unknown. The newly discovered episode involves interbreeding over 700,000 years ago between a distantly related super-archaic population which separated from all other humans around 2 million years ago, and the ancestors of Neanderthals and Denisovans. The super-archaic and Neanderthal Denisovan ancestor populations were more distantly related than any other pair of human populations previously known to interbreed. For example, modern humans and Neanderthals had been separated for about 750,000 years when they interbred. The super-archaics and Neanderthal Denisovan ancestors were separated for well over 1 million years. These findings about the timing in which interbreeding happened in the human lineage is telling something about how long it takes for reproductive isolation to evolve, said Rogers. The authors used other clues in the genomes to estimate when the ancient human population separated and their effective population size. They estimate the super-archaic separated into its own species about 2 million years ago. This agrees with the human fossil evidence in Eurasia that's 1.85 million years old. The researchers also propose that there were 3 waves of human migration into Eurasia. The first was 2 million years ago, and when the super-archaics migrated into Eurasia and expanded into larger population, and then 700,000 years ago, Neanderthal and Denisovan ancestors migrated to Eurasia and quickly interbred with the descendants of the super-archaics. Finally, modern humans expanded into Eurasia 50,000 years ago, where we know they interbred with other ancient humans, including Neanderthals. I've been working for the last couple of years on this different way of analyzing genetic data to find out about history, said Rogers. It's just gratifying that you come up with a different way of looking at the data and you end up discovering things that people have not been able to see with other methods, he said. And this is from University of Utah on SciTech Daily. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.